Now, welcome again to another video which is about Bernoulli differential equation. Now, let's get started. A differential equation is said to be a Bernoulli differential equation if it's written in the form of y prime plus pxy is going to be equal to qx times y to the power of n. As you can see, this part of the equation is similar to the linear differential equation. And the other side, we have qx, which is the same, but which is times 2 y to the power of n. So a particular case, which is n is equal to 0 and n is equal to 1. When we replace n is equal to 0, it's going to be a linear differential equation, since y to the power of n is going to be 1. And when we replace n by 1, it's going to be qx times y. So when we when we subtract this quantity, we will obtain a y prime plus px minus qx all times y is going to be equal to 0. And by considering this is as a px and this is as a qx, we are obtaining a linear differential equation also. So what should we do right now is to see how to solve this kind of differential equation. Let's get started. Uh, as you know that we have, let me rewrite this equation right here. Pxy qxy to the power of n. Yes. As you can see here, so we know how to solve a linear differential equation. So we should return this equation into a linear differential equation to see how to solve it. In the linear differential equation, the thing that we don't have in the equation, which is y to the power of n. So we need to remove y to the power of n, which is by dividing all the equation by y to the power of n. We are going to obtain y prime over y to the power of n plus px times y of minus 1 to the power of 1 minus n. It's going to be equal to qx. It seems like it is a linear, but we need to do some substitution to see if it's a linear. Let's consider this as t, or another variable. T is equal to y to the power of 1 minus n. So by getting the derivative of t, it's going to be t prime is going to be equal 1 minus n times y to the power of minus n times y prime. So t prime over 1 minus n is going to be equal to y prime over y to the power of n. As you can see here, y prime over 1 to the power of n is the same as this. So what should we do is to replace each variable in the equation by what we have found. So it's gonna be t prime, which is t prime over 1 minus n plus px times t is going to be equal to qx. As you can see here, it's the same as a linear differential equation, just we need to multiply by 1 minus n, and we will obtain t prime plus 1 minus n px t is going to be equal to 1 minus n qx. So as you can see here, this is a linear differential equation, and you know how to solve this kind of equation. Then we are going to obtain t as a solution. So when we obtain t as a solution, we need just to get y by using this equality. So let's see some examples to make sure that you have understood. Let's see the first example. The first example said solve the differential equation, which is xy prime plus y is going to be equal to minus xy to the power of 2. So as you can see here, this is a Bernoulli differential equation and it is raised to the power of 2 on this side. So the first thing that we need to do is to divide by y to the power of 2. So we're going to obtain x y prime over y to the power of 2 plus y over y to the power of 2, which is going to be y over y to the power of 2, which is going to be y to the power of minus 1, and it's going to be equal minus x. Then what should we do is to divide by x, since we need to get the coefficient 1, the same as always. So it's going to be y prime over y to the power of 2 plus 1 over x y to the power of minus 1 is going to be equal to minus 1. In this case, we need to substitute t is equal to 1 y to the power of minus 1. So t prime is going to be equal to minus 1 times y prime times y to the power of minus 2. So minus t prime is going to be this quantity, which is the same as this. So we are obtaining minus t prime plus 1 over xt. It's going to be equal to minus 1. So multiplying by minus 1, we are obtaining t prime minus 1 over xt is going to be equal to 1. As you can see here, this is a linear differential equation, and I think that you know how to solve this kind of equation. So by counting exponential to integral of 1 over x dx, and at the end we are obtaining here it's going to be ln x, and by minus it's going to be 1 over x. So by multiplying this equation by 1 over x, we are obtaining 1 over x t prime minus 1 over x squared t is going to be 1 over x. It's going to be the derivative of the product of 1 over x and t. It's going to be equal to 1 over x. By integrating both sides, we're going to obtain 1 over xt is going to be ln x plus c. Multiplying by x, we're going to obtain x ln x plus cx. So as you can see now we have found t. So to obtain a y we need to use this equality. It's going to be t is equal 1 over, we have obtained that t is equal to 1 over y, so which implies that y is going to be equal to 1 over t. So y is going to be equal to 1 over x ln x plus c times x. So this is the general solution for the differential equation that we have seen. Let's see another example. I think when we have dealt with the linear differential equation, now that everything is easy, since this is just a way how to solve a Bernoulli equation. Let's see another example, which says solve the differential equation, of course, which is xy prime plus y is going to be equal to y squared ln x. Yes, the first thing that you need to do is to divide by y to the power of 2, then divide by x. So we're going to obtain y prime over y to the power of 2 plus 1 over x y to the power of minus 1 is going to be equal to ln x over x. Now we will substitute t is equal to y to the power of minus 1, so t prime is going to be minus, which is y prime over y to the power of 2. So we will obtain minus t prime plus 1 over x. T is going to be equal to ln x over x. So by multiplying by minus 1, we're going to obtain t prime minus 1 over xt is going to be equal to minus ln x over x. So now this is a linear differential equation, and you know how to solve this kind of question. So we need, I think it's similar to the first one, so just we need, yes, it is similar to the first one, so just we need to multiply by 1 over x, and we're going to obtain 1 over x, yes, 1 over x t all prime is going to be equal to 1 ln x to over x to the power of 2, yes. So as you can see here, by integrating both sides, we can solve this differential equation. So let's see another example of a Bernoulli differential equation. I think this is a easy way how to solve them, since it's going to be a linear differential. Every Bernoulli equation, we're going to make it as a linear differential equation, and you know how to solve a linear differential equation. All right, this is example number 3. Yes, what we have y prime plus y is going to be equal to xy to the power of 3. So we need to divide by y to the power of 3. We're going to obtain over y to the power of 3 plus y to the power of minus 2. Yes, it's going to be equal to x. So what should we do right now is to put t is equal to y to the power of minus t. T prime is going to be equal minus 2 y prime y to the power of minus 3. So we are obtaining minus 1 over 2 right here. We are going to remove minus 2 from this side. So by replacing in this equation, we're going to obtain minus 1 over 2 t prime plus t is going to be equal to x. By multiplying by minus 2, we're going to obtain t prime minus 2t is going to be minus 2x. So right here we need, we have make it as a linear differential equation. So what should we do is just to calculate exponential to minus 2 dx, and it's going to be equal to minus 2x. So what should we do? Multiplying by this, we're going to obtain exponential minus 2x times t prime minus 2 exponential minus 2xt, and etc. So it's going to be this all prime is going to be equal to minus 2 exponential minus 2x, and this is x. By using integration by parts, we're going to obtain, let me see if I can do it quickly. Yes, it's going to be exponential minus 2xt. It's going to be equal to, let's integrate this and get the derivative of this. So we are going to obtain x, are going to obtain x exponential minus 2x. Then we're going to get the primitive when we, yes, minus I think exponential minus I think 4 minus 4 sorry minus 1 over 2 exponential minus 2x. I'm not sure about the answer. Let me just get the derivative of it. We're going to obtain here x times, we're going to get the derivative of this, which is going to be we are going to get the derivative of this, which is 1 exponential minus 2x, minus 2 exponential minus 2x times x, and this is going to be plus, it's going to be plus exponential minus 2x. So we're going to put a plus right here to get the answer that we are searching for. So it's going to be this. Yes. Now by plus c, we don't forget c. By multiplying by exponential 2x, we're going to obtain t, which is going to be x exponential minus 2x plus 1 over 2 exponential 2x plus c exponential 2x, and t is going to be equal to 1 over y, so we are obtaining by my y is going to be equal to 1 over x exponential minus 2x plus 1 over 2 exponential 2x plus c exponential 2x. So it's going to be, this is the general solution for the equation that we have seen. Now let me give you another example to try to solve it, and I think I'm going to make a video to solve all another examples, and I'll be solving the examples that I'm giving you. So the examples said exercise, we can say it's an exercise. Y prime is going to be equal to 4 over 3 y plus x square root of y. As you can see here, the square root of y is going to be the same as y to the power of 1 over 2. And you can solve it by yourself. I think that you have got the idea how to solve a Bernoulli differential equation. So see you in the next video with Riccati equation, and goodbye.